Good day, learners. Today I'm going to do a lesson of mathematics in grade 9, and the topic is area and perimeter of 2D shapes, and this is going to be lesson 2. And lesson 2, in today's lesson, we're going to cover the area and perimeter of a kite. Okay, before we move on to that lesson, I think we should spend a few minutes to do a quick recap on lesson 1. Lesson 1 dealt with primarily the area and perimeter of a rhombus and a parallelogram. So if I draw quickly a rhombus and a parallelogram, and if I draw a perpendicular height for each of them, and I label that the breadth and that the base, the area would be the base times the height for both. Okay, and if you recall, we did an investigation where we cut out the little triangle and moved it to the other side so that it formed that rectangle or that square that we are so used to seeing. Okay, so let's move on to the area of a kite. So to determine the area of a kite, we have to do a small investigation. Draw kite quickly. Please excuse the kite if it's not drawn to scale. Okay, so what are the properties of a kite that we know? So the most important property, or one of the most important properties, is that the adjacent sides are equal. And another important property to note is that the diagonals will cross. And when they cross, they will cross at 90 degrees. There's one diagonal, and here's the other diagonal. And here they will cross at 90. Okay, so to begin this investigation, the first thing we're going to do is we're going to recognize this shape right here. Within my kite, I have a triangle. Specifically, it is an isosceles triangle. We know it's an isosceles triangle because two sides are equal. And if I look at the other side of my kite, what do I have here? Yes, I have another triangle. And what type of triangle is that? It's also an isosceles triangle. So, if we work out the area of one triangle and work out the area of the second triangle and sum them up, that's one way of getting the area of my kite. So, let's do that. So the area of a triangle is equal to half base times height. Okay? And the area of this triangle is also half base times height. Now, before we go further, let's give this kite some letters. D, E, F, G. So as I mentioned before, the area of a kite is going to be the area of one triangle. So let's call that triangle DEG plus the area of my second triangle, which is EFG. So this area of this triangle plus the area of that triangle. And let's go a bit further. Half base times height plus half base times height. Now, in triangle DEG, what is my base? Right, it's EG. So half of EG times my height is OD plus half of my half. And what is my base for triangle EFG? Again, it's EG. So half of EG multiplied by OF. O is there. Now we can take out a factor here. These two are common. I can take out a factor. Half EG, and I'll be left with OD plus OF. Now let's look at that. OD plus OF. OD is this, plus OF is that. OD plus OF, we can just rewrite that as DF. And what is DF? DF is one of my diagonals. So half EG multiplied by DF. And what are EG? What are EG and DF? They are my diagonals. So the area of my kite is equal to half the product of diagonal 1 times diagonal 2. That's the formula of a kite. Okay, and let's do a quick example. Okay, say I have a kite. And we call this kite A, B, C, D. So because it's a kite, we know that the adjacent sides are equal. They tell us that OB is equal to OD, and that's equal to 6. So that's 6, and that's 6. They tell us that OC is equal to 15. So OC is equal to 15. And they tell us that AD is equal to 10. Okay. And the question says, calculate the area of this kite. So the first thing we should do is we write down our formula. So half the product of my diagonals. So half of AC multiplied by BD. If you look closely, we can see that BD is 6 plus 6, which is 12. So half of AC multiplied by 12. Now we have to work out AC. we know that AC is equal to AO plus OC. And we know that OC is equal to 15. So all we need to work out is AO. And AO is quite simple to work out. We can use a theorem that you have studied called the theorem of Pythagoras. AOP. Now, the theorem of Pythagoras states that the hypotenuse squared is equal to the sum of the other two side squares. So 10 squared is equal to AO squared plus OD squared. Since we want this, we can say that 10 squared minus 6 squared is equal to AO squared. We have 100 minus 36 is equal to AO squared. And then AO is equal to the square root of 100 minus 36, which is 8. Now we can take this value, substitute it in there. AC will be 8 plus 15, which is equal to 23. Now we can take this value, substitute it back. So the area of my kite is equal to half of 12 multiplied by 23, and that's going to give me 138. But since they did not give us the units, we will write units squared. Okay. To consolidate, it is important to know that the angle where the diagonals cross is 90 degrees. And since they are 90 degrees, we are essentially forming 1, 2, 3, 4 right angle triangles. And we can use the theorem of Pythagoras to solve for any one of the sides that we want. Okay, thank you, learners.